Hello everyone, today we're going to look at usaco-training SuperPrime rib. Okay, so in this problem we're given a number n, which is in the range from 1 to 8, and then we're supposed to print all the SuperPrime rib numbers in ascending order. And a SuperPrime rib number is basically an n-digit number, which has which basically each like prefix of the number is a prime. So for this example, the prefix can be 7 is 73, 733, and 7,331. And then since all of these are a prime, then this would be counted as a superprime rib. Okay, so in this example, we're given n equals 4. And then here's our superprime ribs of length n. For example, you can see this. Okay, so we have 2, which we know is a prime. 23 is also a prime. 239 is also a prime. And 2,393 is also a prime. Okay, so we can actually make a constructive approach. So we're given n, let's just say equal 4. Since basically you know that here is our resulting number, where each of these represent a digit. Okay, so we have to make sure this is a prime. We have to make sure this is a prime. This is a prime. Okay. Since all these ranges have to be a prime, we can basically start off with n equals 1. And we know the answer for n equals 1 is 2, 3, 2, 3, 5, and 7. Because these are the one-digit primes. So now to make n equals 2, which means that here we have, let's actually use blue here. So we know since this is only 1, and here we have 2, and then you have to make sure that both this range and this range is a prime. Then you can just loop through all the n equals 1, solutions. Then you would get this position. And then all you need to do is to try to add a new digit. That means that, for example, for 2, you can try to add, let's just say you can try to add 1. Since 21 is not a prime, then you don't append it to your solutions for n equals 2. Then you can check for, let's just say, the first digit is 2, and then the second digit is 3. Since 23 is a prime, then you could append it to your answer. And then you would just basically keep track of the answers so far. So I'm just going to skip this, and then over here we have, let's just say we're done with n equals 2. Now we're doing n equals 3. So now we have a 3-digit number. And basically, here, all these numbers belong in the solutions of n equals 2. Because, basically, let me just erase that. Basically, we know that this thing must be a prime, and this thing also has to be a prime. And since that is exactly what we have over here, we can just use these solutions from n equals 2. And then we just basically add a digit from 1 to 9. Or actually 0 to 9. And then we just check it if it works. So let's just write the algorithm out. So we know that our base case for n equals 1, we know that this is, since all the one-digit primes are 2, 3, 5, and 7, we know that this is our solutions for n equals 1. So then, basically, let's call this n plum actually. So for each n plum from, now you need to calculate it from 2 to n. You need to basically use the last one. So for example, you know that the previous one is this. So basically, you're going to try to add a digit to each of the solutions from the previous one, to n plum minus 1's solutions. Okay, so basically, for each digit, you can basically add from, it'll be from 1, or actually 0 to 9. And then we just have to check if this number is a prime. If it is, we just append it to the solution. If it's not, then we just don't. And then our answer is basically what we get for our solutions for n equals n. Okay, so here we go. Let's include our, whoops. Okay, so we're reading from s prime dot in and we're writing to s prime dot out. Okay, so we're given n, so we have to read n. Okay, so let us have like a vector representing our numbers. So then we can have this, we can have a vector of int, call this basically our current one. So then originally for n equals 1, your current would be equal to 2, 3, 5, and 7, since this is basically our base primes. So now for each, or basically for each of our n plum from 2 to n, we need to store, we need to like calculate our new answer. So basically n equals 2 to n. Okay. So we're going to try to append a digit to each of these numbers. Okay, so to do this, we have to loop through each of these. So let's just, actually it's 4. So for each integer x and current, let's actually call our next, have a next one. So basically in the beginning, our next should be empty, next.clear. Then our basically we're going to try to add a digit to x. So then basically the original one would be x, and then it would be equal to 10 times x plus whatever digit you're adding. So then you could just you could just multiply it by 10. Okay, we're expecting something. Let's see, that's weird. Okay, so then we're going to try to add a digit. So then you can loop through each digit. Let's call it d over here. Notice that it has to be odd, since each prime number except for 2 ends in an odd number. Okay, so you have to add 2 each time. So now we should make a prime like function to check if it's a prime. So we're given a number x. Okay. So since we have to check if it has any factors, or if it is divisible by anything. So basically, if let's just say y equals to 1, y times y has to be less than or equal to x. So basically, if x mod y, if it's equal to 0, then you have to return false since it has a factor. Otherwise, you would just return true. So now, basically, let's actually make this neater. Okay, so basically if x plus d, because this is currently x, and if we add d, so if this is a prime, then our next can append our x plus d. Okay. So now, after this, we need to, actually it should be over here. We need to put our our next into our current. So then you would do this. So you just swap next cur. So after this, you would just print out your elements of your current one, which is basically the answer. So you could do for each integer in current, you just see, actually it's f out x and line. Okay, let me see what the error is. So reading n. Okay, that's weird. I have a breakpoint here. Okay, I'll just run the input. So for example, we have 4. Okay, let me run this. So this is SuperPrime rib, and you just run this. Okay, it's running. For each x in that, yeah. Says that we didn't have a breakpoint. Okay, finish running. Okay, it looks like we do not have anything. Okay, wait, let me actually double check again. Let's just actually use cout so we can just see it in the terminal. Okay, compiling. Okay. Let's actually just put in my login info first. This problem is S prime and the language is C++11. Okay, so it looks like it did not print anything. Okay, so first we can basically check if our prime function is correct. So now we can do this. Okay, so basically we can print if let's just say 2 is prime, we can print, let's just say if 23 is prime. Okay, let's print if, whoops, let's print if 4 is a prime. Okay, so it looks like for all of these, you see that it is not a prime. It looks like, oh yeah, so over here, since every number is divisible by 1, because it's equal to 1 times the number, you shouldn't include 1 in this. So we actually made a mistake on that. Right? So I think that looks like the correct answer. Yeah, so let me just remove the cout and change it to f out. Let's actually submit it. Okay, so let me select the file. Okay, this is SuperPrime rib. SuperPrime rib and main.cpp. Okay, so it looks like that is right. So if you have any questions, feel free to leave them in the comment section below. Bye.